Hello and welcome to OSDR Chats. Today we have the opportunity to speak with Dr. Andrea Camera from the Institute of Basic Medical Sciences at the University of Oslo. Dr. Camera and team analyzed 7 datasets available from the Open Science Data Repository, and the results suggest the need for a frailty index to monitor astronaut health. In this interview, Dr. Camera shares his research with us and describes how the Open Science data systems and the analysis working groups contributed to this publication. Thanks for joining us today, Dr. Camera. Could you please highlight the most important finding in your study?
Great to see you, Jennifer. So yes, there are features of space exposure that resemble the aging process. And examples, for instance, can include DNA damage and oxidative stress from chronic low-grade radiation exposure, for example. And our question is whether this kind of chronic attrition induces aging-like features in astronauts. And to that end, we focused on the frailty syndrome, which is a condition typical of aging and which tend to manifest itself as a physical decline. An example, for instance, is muscle impairment that you could see in elderly patients. And frailty is a syndrome which is deeply rooted in aging biology. And that's why it seemed to us as a pertinent condition to investigate this matter, since it is a crossroad between molecular changes of the aging process and the physical, phenotypical alterations that become manifest in the clinic, and so would be visible in astronauts. So our most important finding is that we identified alterations in frailty-related biomarkers triggered by spaceflight in both animal models and astronauts. And these changes in gene expression, which are putatively linked to frailty, suggest that these markers could indicate physiological changes during spaceflight, much like their potential use as a clinical assessment tool on Earth in this case. And crucially, also, this is quite important to note, some biomarker alterations persisted after re-entry, and this challenged the notion that all spaceflight-induced physiological changes revert to normal after the mission, post-flight. So while these findings are preliminary and do not demonstrate the development of frailty in astronauts, they, however, hint at a potential common background, which might be exacerbated by chronic exposure to space. And this is a very novel topic, and we need further validation to deepen our understanding of it and their real global impact on astronaut health.
This is both fascinating and valuable, and I look forward to your further studies. My second question is, how did the Open Science data systems or the analysis working groups help assist you in your work so you could achieve these research goals?
Oh, the OSDR has been fundamental for our investigation. And because this data bank allowed us access to a large amount of open access spaceflight data that were relevant for our research question, as we need, for instance, multiple independent data sets to test our hypothesis on, and OSDR has them. And also the AWG community that is at the heart and is the driver of this initiative. And I believe this community, it's an outstanding example of how scientists and students in different parts of the globe can join together to pursue a common interest and can share knowledge and methods within each other.
I'm really glad you're part of this community, and I'm really glad to hear about your positive experiences with the AWGs and with the OSDR. And of course, thank you for sharing your time with us today and with our viewers. And to our audience out there, you can learn more about this work, how to join the analysis working groups, and access the datasets analyzed in this work with the links provided in the description section below. Thank you and have a great day.
Thank you, Jennifer. Bye.